Hello, hello, beautiful people. Thank you for coming to our last Global Hack Week session for AI and ML Week. Oops. My name is Isa. I am a coach here at Major League Hacking. My pronouns are she and her. And a fun fact about me is I've seen a lot of anime. Um, oh, so today we are going to talk about the gap between using AI models versus, or making AI models versus using AI tools. And I figured that this would be an interesting topic for y'all since the since the products of OpenAI blew up, like ChatGPT, Dolly, all of that stuff. Um, and I've noticed that folks going into AI may not be aware of, for example, how difficult it could be to create something from scratch versus um, creating an application using something that's ready made. Like the level of abstraction, I want to say, like if we want to use fancy terms, is sometimes not noticed by folks on either side of AI. If you do recognize me, hi. Yes, please type in chat. Let me know you're here, and or if you have any questions, opinions about the stuff that I'm talking about, please feel free. Um, but yeah, I'm just gonna go into it. I wanted to start with kind of like an overview of how we got to where we are in AI. I do not want that. We just wanted to shut that up. Thank you. So, I wanted to talk about how we got to this point in artificial intelligence. So, a little bit about history, and then talk about what it's like to develop artificial intelligence from scratch versus how to create consumer facing products that utilizes AI tools, and some examples of how, or of some like real world examples of how that experience is different. Cool. So, a brief history in AI. I kind of went over it in a previous workshop or session, tweaked it a little bit to make it not the focus of this session. But if you want to look into that, all of my slides are always up on the same place. So artificial intelligence started in academia in the 50s. So this is schools, universities, laboratories, because computer science doesn't really use a lab. And when you envision a lab, it's more like test tubes and petri dishes and that kind of stuff. Um, but it started in academia where the computer scientists were trying to make computers at the same level of intelligence as humans. So AI was always touted, I think is a word, that to either compare to a human being's intelligence. Um, uh, Later on, I'll go into how that has shifted in today's world. But in the 80s or 70s, governments and corporations started to get involved, but they almost always underestimated the work. An example of this is in Life magazine. I don't know who Minsky is, but I'm assuming he's an important person, um, since he was in Life magazine. But basically, he said that in 8 years, so in 1978, you're not late. Don't worry. I This is my first like content slide, but we're just talking about um, AI models versus AI tools. So um, this person predicted that by 1978 max, they would already have a machine that's capable of average human intelligence. Um, and part of this prediction was that the proof of concept wasn't difficult. Like they could say that it's possible, but to the point of making it usable, that gap is much bigger than anyone anticipated. Um, where, for example, we could theoretically, let's say computer vision, because that's the one that like makes the easiest sense to me. we could easily like make a proof of concept that um, we could differentiate um, a dog from a bag of chips. Like those are very, very different. Um, and that proof of concept is relatively easy to get to. But when we want to make something more usable, like let's say cat versus dog, or more specifically breeds of dog, um, then it becomes much more difficult because the proof of concept got us there. Like we can differentiate things, but then the nuances of um, this, like if a human being can't tell, like what are very similar dogs? I don't know, but uh, another way to explain this would be if the differences become less obvious. If we have a hard time explaining it, then a computer might also have a hard time explaining it. Or because the way that we have developed artificial intelligence is based on people, it's limited by people, you know? Um, I'm also going to go into other other things that limited our AI research. But yeah, so because of this prediction, as well as multiple other predictions of how AI research was going to go, and then they didn't meet those timelines, both the researchers and the investors of those research started to get discouraged. So there was a lull in both funding and research by the time the 80s came in. Um, Later on, around the 90s, 2000s, the rise of big data, as well as just it became a little more normal to collect data as time went on. And then with the rise of big data, everyone collected data. So we had more to work with. So the training of those AI models increased in both breadth, so different use cases, as well as accuracy, specificity in the use case. So that means all animals versus specific breed of animal, you know? Um, but now so this last bullet point is a little bit a personal observation. I didn't like fact check this one, but I think it's becoming less about mimicking people. And it's also that researchers in academia got backlash on, for example, AI ethics. Like, if we're trying to make it like humans, what if it replaces humans? Um, with that, like, conflict, the narrative became that it was about surpassing human limitations. Like, we can't look at 5 classes in um, like a model can, because when we in our brains visualize it, like think of math, like uh, the Cartesian plane, like just the regular like 4 point graph. That's 2 dimensional, 1 dimension, 2 dimension. And then once we start thinking of a third class or a third dimension or a third feature to consider in our calculations, it becomes 3 dimensional. And then based on where our physics research has like capped or stopped at this point, we don't know how to visualize fourth, fifth, sixth dimensions. So it's just a human limitation to not be able to process that many classes, that many features in the way that we know how. So surpassing those human limitations, or our own human processing power, has become more of the um, focus of AI. Awesome. You're not really trying to build, oh, for everyone to see, as giving them feelings that they may lead to something we watch in sci-fi movies. That's true. Weak AI to serve our purposes according to our daily needs. I do agree with that. Where, for example, the image that you see on the right of the screen is a female computer scientist from MIT in the 2000s. She made Kismet, which was a robot that simulated human reactions, like the facial expressions, and they called that AI. Um, because it was artificially mimicking the intelligence of human like emotional intelligence. Um, and now we've kind of separated ourselves, like put a distance between the humanity of us and the becoming humanity of AI. Wow, that sounds very sci-fi and like um, conspiracy theory y. But I do agree that that distance where like we only work on the purpose that we need, like AI generated art or AI generated music or recommendation systems or chatbots. So it is no longer a generalized, here are things humans can do. It has become, here is a thing that humans have not entirely mastered. So let's use AI in this specific use case. That's a good point. I didn't like um, think of that angle where we're going towards specificity um, and less about humanity or emotions per se. Um, oh, another thing, a last point that I wanted to make in terms of like history and AI is that in AI research, another limitation aside from like humans or our capacity to understand, I don't know, the concepts behind AI is the computational power. Just like before, we would work on just computers like our desktops, like around the same processing power, and then we needed supercomputers, and then we needed, and now when we like regular developers want to train AI models, we often use virtual machines or like cloud services just for the training so that we have stronger computational power, so storage as well as processing speed. Um, and we kind of just have to wait for that. Like it's a balancing act of both software and hardware when developing AI is the point that I'm making with that one. Awesome. So I wanted to go into developing AI from scratch as opposed to utilizing AI tools. So when we develop AI, I'm thinking of like at the most basic machine learning decision trees or going into natural language processing, like the breaking down of um, grammar structure or the knowledge of linguistics, that kind of stuff. So when you develop AI from scratch, it usually requires a graduate degree. So I wanted to mention this one because folks who might be super duper interested in AI because they saw what ChatGPT was capable of, and then they might not realize that you need more, like much more education what if you want to develop at that level versus if you just use ChatGPT in like an app that you are developing. So from scratch requires a graduate degree either in the underlying field, so natural language processing, computer vision, um, like the functions that create the model, or the topic. So if you're interested in AI within bioinformatics or AI within economics, like think stock ticker stuff, um, though, like when you apply for AI specific jobs, they're usually going to ask for either a master's or a PhD. In academia, it's usually master's is enough. And then if you're going into academia, did I use the words that came through my head? Industry is usually master's is enough. And then when you go into academia, PhD is usually more of what they're looking for, or like postdoctorates, stuff like that. Um, and that is because the level of specificity um, becomes more necessary. So, for example, it could take um, as simple as changing the way that you blur an image to recognize the edges. To like, it takes very tiny, like niche tweaks, not tiny because it's not like not a lot of work, but more so it's like a very specific detail. Um, if you want to tweak an AI model, you usually have to understand the underlying um, functions or topics, um, because yeah, and as mentioned, more often done in academia versus industry. Um, on the other hand, utilizing AI tools, the best part about it is it makes AI accessible regardless of your skill level. This means even um, people who are software engineers who usually only have a bachelor's degree, they can use AI tools and make wonderful projects or wonderful products, like a commercially viable product, um, regardless of their skill level. Um, Unfortunately, what I've seen happen if you only use AI tools and don't understand the AI model behind it is that you can't decide which tool is better for your specific use case. Um, for example, like if you want to predict if a okay, just like from my own personal experience, I had a project that was basically um, uh, diagnostic tool, like very bottom line. That's not where I ended up, but that was like the bottom line that I was aiming for. Um, was a diagnostic tool, and if I didn't understand, like without an understanding of AI models, I would just be like, okay, what prediction thing could I use? And I would uh, just choose them based on their accuracy on, for example, my specific data set without understanding why it works for this data set. But when I did my research on, like, from, it wasn't entirely from scratch, I don't think. Like, very base level from scratch, because I still used, like, functions within R. Um, so there are levels of abstraction to it, from making the functions that make the model, making the model, using the model in an app, and then at the very top would be things like mid journey, midsummer, something like that, where like you just put the phrase that you want and then it generates it for you. Like that's still an AI tool, but you're so far removed from the code, you don't know how it's doing it. I kind of like how I said that. Um, but if you don't know which tool is better for your specific use case, it might be that the accuracy will drop the moment you use a different data set. So if we're another way of looking at it is if we use an AI, a chatbot, for example, and you use this chatbot and this model is very good for example, um, just like an assistant on a website that helps direct you to the right page. Like it works there. It's too hectic to make model from scratch. That is true. Um, then I guess another point that I would want to make, or like another slide that we could like have a separate thing on, is when to develop versus utilize. But yeah, it. Um, so good segue into the third point of utilizing AI tools in the software industry is very common because for us, yes, it's too hectic. Why bother reinventing the wheel? If it works, it works. Like those kinds of mentalities. If it serves our purpose according to our daily needs, then we can save a lot of effort, a lot of work, a lot of research, and just use the thing. It makes it accessible, yeah. But caveat that I want to point out is if you're making a product that you want to become a startup, or if you're making a company, something along those lines, then you would need a unique selling point. Like if you're, for example, using AI from Google Cloud, like their out of the box features, um, Google Cloud gives that to like not gives, but like allows any developer, Google developer, to use it. So what's your unique selling point? What makes your product any different from anyone else that also uses Google Cloud? With that in mind, then you might have to reinvent the wheel in a way that is specific to your users or is more efficient in a general way. Those unique selling points, you would have to develop the AI from scratch. But for every other use case, utilizing a tool that already does the job for you is more than enough. Um, Someone shared that the pre-processing and dealing with empty and outlier data and feature selection, and finally seeing overfitting and underfitting in development issue. That's very fascinating. So when folks use AI tools, like when I've um, taught at hackathon workshops with like a lot of beginners and they want to use AI, they usually don't understand like overfitting versus underfitting because they only have their one data set that they know they're going to use. Um, they won't have to try it out on different use cases before it's ready for the world to see. Um, so these are issues that not everyone is going to face. But yeah, I guess I thought it would be worthwhile to see the bottom half of the iceberg of artificial intelligence now that ChatGPT and um, Dolly and Midjourney and what other fun AI tools do we have coming out? Lots of AI generated art competitors. And then they make like specific use cases. Like I tried an AI tool that specifically generated concept art for video games, and the demos that everyone else had were really good, but the moment it stopped, it went out of the use case. Like I thought the way the like the assets for the world, I don't know what they're called, but like the houses, the grass, the map, like the environment of the game. I wanted to use that model to build something for, what was I trying to make? Yeah, just like a concept art. And the moment that it wasn't for the game anymore or for a game anymore, the tool was like subpar, if not useless. Um, if I knew how the AI tools worked, I could better choose which one would fit my needs or be more efficient, stuff like that. And yes, the Bard AI was apparently a mess, uh, would be a light way of saying it. Um, I'm a little curious as to how they implemented it. Like, what could have gone wrong? Like, how would they fix that bug? But unless they hire me, I can't look at the code. But it's just like a fascinating thing that, like, how, like, what didn't they account for that they should have accounted for when they created this, when they created Bard? Bard is catchy enough that like Google it. You just say ask Bard. Good branding, good branding. Um, but yeah, so the it's only been 25 minutes. That's bonkers. I The last thing I wanted to go into was examples of like image recognition models versus AI generated art, which I kind of sort of already got into. Um, but on one hand, we have all of these steps. I started breaking it down super duper simple by with like number one and number two. By number three and number four, it was just like I can't comprehend the complexity that went into edge detection um, in a short enough amount of time. And then when it went into feature extraction, I was like, how can it tell? Because like if you want to be able to tell like a water bottle from a fox, then yeah, feature extraction is super duper easy. But then I started thinking about like I wanted to make ASL translations for my capstone project. And I saw it on DevPost a lot. So I was like, oh yeah, this is totally doable. If they can do it in a weekend, I can do it in a semester. Capstone is like my thesis for um, to before graduation, and that's what I wanted to make. But then, so for American Sign Language, it's like there's one sign for every letter, for every number, and then you start generalizing to specific phrases like thank you or I love you or good morning. And then the complexity that's like layer of complexity. So letters, phrases, and then you start going into sentence structure. Like I don't know. If anyone knows this, put them in the chat. But I'm going to the movies versus the movies is where I'm going to. Like, would that make a difference in sign language? Because when we're speaking, it makes a difference. And that affects our speech to text models or our natural language processing models. But in sign language, I wonder if the way that they sign would be more general, just like subject verb, which would go into linguistics. But basically, yeah, like that layer, those layers make it really hard as you go along. Um, so like I started looking into it, and by the end of that like class, that lecture, we basically came to the conclusion that it was like too big of a use case, and if we narrowed it down, it would be useless because the hackathon projects all used AI tools. So I guess what I was getting at with this example was that it's what inspired this session of all of the hackathon projects used AI tools to not all, most, and then some of them used GitHub repos, which technically aren't tools because they were still coded from scratch using libraries like OpenCV or TensorFlow or stuff like that. That is also another layer. Um, but the the examples that I saw that did ASL translation only did the letters. But if you're familiar with ASL, it's not static. Like it's not just like here have letter A, here have letter B, here have letter C. Because later on you will have, for example, letter Z. You have to physically move in the shape of a letter Z. But if it's a picture, you can't show this. Like it'll look like you're just pointing. So that's a layer of complexity that then becomes something that someone with a graduate degree or has knowledge in like from scratch development would be able to accomplish. There was also the layer of and then I think this one is more of a hardware limit than a software or brain like research limit, like human research limit. But letter S is like this. I'm trying to like have a background. So letter S is like this. The thumb is on the outside. But letter M is inside. It still looks like a fist, but if you look really closely, my thumb is sticking out after the third digit or the third finger. If your camera is like mine, which is just a webcam, is a little janky, it won't like you won't be able to see it clearly, and the AI model won't be able to differentiate. Remember, we mentioned edge detection. It won't be able to tell my tiny little thumb on that edge. So how else can we differentiate M and S, right? And then we go into feature extraction of like the color. So one way to, for example, differentiate letter S and letter M would be if we manipulate all the other factors. Like if it was always on a dark background and it was always a relatively light skinned person, so there was enough contrast so you could see the edges, but then what about lighting? Then I would have to move super duper close to do M versus S, right? Um, but yeah, though. So number three and number four in terms of steps was super duper like it was a rabbit hole is what I'm trying to say. It's a whole rabbit hole to go into to detect edges, to extract features, but then once you want that to be usable, like because for example in a hackathon perspective, sometimes we want to make a mobile app because it just fits our idea better, but we usually like folks usually stick to websites because it's easier, it's faster, it's what they know already really well. But if we want to make it usable, if we want to get folks to actually use it, then AI models like image recognition, image classification. No, image classification can be static, like you can just upload a photo. But for stuff like the translation, it has to be real time. There's no other way to use, like, for it to be usable to the general audience, to consumers, if it's not real time. And that one, I could not break it down further. It was just like number five, this. Um, just like take a leap of faith. But yeah, that's super duper like difficult. Um, and yeah, I see someone in the chat, and after that, I'm going to go into homography, which I thought was fascinating, but it's slightly tangential. Um, what is the session program plan? Mark the online attendance. Got you. So, session program plan is I'm just going over the gap between AI models and AI tools. I kind of almost finished everything I wanted to go over. I uh, was expecting like to pause for questions and stuff, and I guess I'm just going through examples now of differences in making AI versus using AI in terms of like the experience of either the developer or the consumer. And for the online attendance, I'm so glad you reminded me. I'm gonna copy and paste it into the chat right now. Cool. You should have that now. And then I'll keep it up just for a little bit. So you know it exists, even though you probably can't copy and paste it from the screen. But yeah, so I also want to put, where's that thing? This. So if you have any questions, put them in the chat. And then in the meantime, I'm going to ramble about homography, which I thought was super duper cool. It's basically if you have, like, if you're scanning an image, for example, or like a piece of paper, which I'm now trying to look for. Ooh, you'll see my bullet journal. So let's say I want to scan this, right? If it's like this, if it's like at an angle, how do I make it so that the image shows you in a way that it's still readable? Homography is then the it's like image science, but also math science. Um, I don't know the specific field it falls under, but homography is changing that tilted image that way. So if you're scanning documents, right? And I find this interesting because it doesn't, like, when you're going through, like, let's say you're making an image recognition model, or actually, um, let's say, okay, new slide. Let's say my use case, you're going to hear the clacking of my keyboard. It's okay. Let's say the use case is taking notes and translating it, right? Taking handwritten notes and translating it. So this kind of project would be best for a and then I want my next use case to be, let's see, what's something that would fit AI research much better? Oh, the ASL one. Yeah. So I rambled on it, but I didn't type it out. This one, you'd need Spanish. I might fill out these slides before I give them to everyone if anyone wants the slides, if at all. But here, because it's a more specific use case, or because there are lots and lots and lots of moving parts, it would be better to use a tool. Because like I'm thinking about it and ooh, my pause reading it aloud. So this could be if you wanted something accessible. Oh, both of them are accessibility. So if you want to take handwritten notes and translate it, first we would have to go through computer vision, right? To get the image of the notes. And then that would include recognizing the edges of the paper. And then these are like just breaking it down into the pieces that create the tool. So we're recognizing the edges of the paper, and then the term is OCR. If anyone wants to save me a Google search and let me know what OCR stands for in the chat so I can copy and paste it here. But it basically means taking the letters and translating them into like typed up letters. That would be an image recognition like tool function thing that I don't know if there's a lag or if no one's listening, but OCR meaning optical, gosh. So it's optical character recognition. That's what I mean. When I first learned of OCR, I wanted to translate manga, like get rid of scanlation jobs entirely. But optical character recognition would recognize letters on paper. And then once you have the letters, you would then have to translate it. Or not even yet. Okay, so we're going to say translate, right? But before we get there, we'd have to turn them from individual letters into like a paragraph of text. Letters to paragraphs, right? Which would mean, or is that does that go within recognize the edges of the paper? Plus, the reason why I brought this up was because what was that new thing that I learned? Homography. Yeah. So, including homography. Recognize the letters on the paper, turn the letters into paragraphs, which would be, I think I want to say, what do you call it when you change it into a form of data that you can work with? I don't know. Turn into data structure is, I guess, what I want to say. Turn into data structure. Data structure. And then we're going to go into natural language processing, which would then require translation And then now we're into speech to text. No, text to speech. So text to. Yeah. I guess I know more about CV than the other kinds of AI, because that was the one that I was able to break down into pieces. But I took it was like computer theory, which was like a really big precursor to NLP. But I don't remember the pieces. Which would include linguistics, grammar, sentence structure, etc. Yeah. So instead of, because the way that I'm seeing computer vision is the steps of like the functions that you would need to apply onto the image. Natural language processing is more like conditions or considerations to the thing that you're working on. Like, plus like spelling. But in this use case doesn't care about that. But that's just like something that's worth, that's within NLP. But yeah. So, and then text to speech would be the final thing. So all of these different steps would create the singular use case of translating handwritten notes. Reading, reading translated handwritten notes out loud. Yeah. So the reading is one, the translation is one, the handwriting is one. That would, as Nishu mentioned earlier, it's hectic to have to create all of those from scratch. Even just like the homography part, I remember having to, like, my project for Hacker 413, was it? Was measuring the distance between 2 points. Way before the prevalence of AI tools, like 2019. And that's where I learned about homography, because I wanted to measure the distance, the width of a door, but then what if the door was taken at an angle? Then it throws off my function to just count how many pixels. And it took a physics major and a math major with like a photography hobbyist to explain all of that stuff, which is just measuring the distance, or like, yeah, measuring the distance. And yet I think the use case that we found that at was iPhones come built in with a camera that like it ARs the ruler onto the surface that you're measuring. And we wanted to make something like that from scratch. And the most that we could do was how many pixels, or therefore inches, is there between this side of the door to the other side of the door. And it was quite a wake-up call into how complicated AI just is. That's a good like closing remark, I guess. Unless anyone else has any questions, or like last minute additions, or any personal experiences with AI that they want to share, or maybe a use case that they want to explore together. But yeah, I'm just chilling with my iceberg. If you guys want to talk about, I guess, how to get into AI, or where AI is going, I don't know, we can just chit chat. Otherwise, I can end the stream. I know it is the last day of Global Hack Week, for this month. Next month, we're doing something different. If you looked at the website, we're doing social good, which is pretty cool. It not sure how the streams are going to go that way. Is it that we're going to talk about the different issues of the world that needs work fixing, or specific technologies that are coming up that would solve world problems? I would probably want to, now I'm thinking about it, right? Like climate tech, eh, which relates back to the iceberg that I didn't mean to relate back to the iceberg, but climate tech of like how to integrate the adapted algorithm model in the artificial intelligence AI pipeline process. Adapted algorithm model. I'm like trying to understand the question. Adapt algorithm. Is it a reference I'm not familiar with? Adapted algorithm model, sorry. Oh! Do you mean adaptive ML? I'm looking at this. Is this what you mean? Oh, just in case. I'll wait for if this is what you mean. But in the meantime, I can look into it. Because usually what happens with I have like, it sounds conceited, but a wealth of information. I just don't know what they're called. Like I knew what homography was and how to do homography, but I didn't know the word was homography. I kind of just like logicked my way to it. Um, but catastrophic interference. Oh yeah. So my knowledge of machine learning was like so basic back then because I learned ML back in 2017 when neural networks weren't prevalent yet, and I still have a weak understanding of neural networks, but I can explain at a higher level. But I can't explain the networkness or the neuralness of the network, I guess. So follow up was deploy the adapted algorithm model. Oh, so just based on the word deploy, I would like to present to you cloud.google.com. So that's where I'm going. And then products, and then AI and machine learning. And we're just going to go through all of these. So what you're looking for, because you said deploy, might be the AI infrastructure, right? Which would refer to the processing of the model, like getting a better processing power for your model, which would include, the hardware stuff, so processing power, speed, etc. Low latency, just so it's available at all times. Large scale trading, which would be if you have a giant data set. And then this is telling me that it's, what's the word I'm looking for? Yeah, AI algorithms versus AI tools. This is still an algorithm, not a tool. So in terms of levels of complexity, it's still way up there. I want to look through what AlphaFold is and what TabNet is. I'm just going to go through a rabbit hole in front of y'all. So, cloud TPU, tensor processing unit. That's really cool. That's really cool. It's a CPU especially for AI. That's pretty cool. Okay, cool. I want to know that. How it's fine-tuned for deep learning. How to reduce error ratio of algorithm. So that I can answer from like a higher level perspective, or like from a higher level overview. Work on lots of different data sets. So even if you have, so what I mean by this is not just have a 10,000 point data set, but have multiple different data sets, regardless of how big they are. Maybe you could have one that's just a few thousand versus one that's like 100K data points. Um, Having that variability will increase the accuracy of your model. But as I'm saying that out loud, numerically, like from a numbers point of view, it won't be as high, but you don't want a completely perfect AI model yet. Yeah, because if you have a very, very accurate model, let's say 90 something percent accuracy, but you tested it on a small data set, or you didn't separate your training, test, and validation, or you have a very narrow use case, then your number is going to be high. Your accuracy number by itself is going to be really high, but you can't use it outside of that data set. Um, so your error ratio is going to be low, like it doesn't have a lot of mistakes, but you can't use it outside of where it's used, where you've tested it on. Does that make sense? Um, so it is a balancing act of keeping it accurate, but keeping it usable in terms of error specifically. Because then, oh, there's also, if you want to be super duper specific about it, of like developing it from scratch versus using a tool, confusion matrices, I remember those, where like you're supposed to, or like it measures um, false positives versus false negatives, true positive, true negative, etc. And it's important to oh, that's a good point for that slide that I had that one time, um, about gosh, oh, where's my slide? Where's my slide? Um, we're gonna go back and um, the one that I wanted was this. Cool. So um, here in AI tools, I remembered that what I was excited to relate it back to, but then what I was trying to relate in the first place was gone. Um, Gosh. We were talking about, oh, confusion matrices, right? And oh, yeah, 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 yeah. So folks don't know which tool is better for their specific use case. On a very, very lower level, like basic level, it's also about like which is more tolerable, false positive or false negative. That's also something worth noting. Because, for example, in my use case for the diagnostic tool that I mentioned, we had to discuss, is it better to tell someone they have multiple sclerosis when they don't have it, or tell them they don't have multiple sclerosis when they do actually have it? Which both are really bad, but it's also worth noting like which one is worse, which use case, like which one would you want to prioritize or would you want to optimize against? False positive or false negative? So that was I finally got it. But next question was, select the best match AI model to deploy for each use case. Okay, very good. Awesome. This is something I can go down a rabbit hole with. Um, those are not AI models, is where I want to start. Because linear regression versus, like, you're seeing like graphs, right? Like, you're seeing a two-dimensional graph of, like, it's when we do linear regressions and that kind of stuff, it's just a Cartesian plane. That is machine learning at best. Um, when you work with numbers and stuff, it's usually just machine learning. Whereas when you start getting into um, conditions, or if you start going into recognition versus classification, because when image recognition is this a dog or is it a Pringles can? Whereas image classification, oh, no. I take it back. Image classification is dog versus Pringles can. Image recognition is which of these pixels counts as the Pringle can next to the which pixels are next to the dog or are the dog. So that level of specificity, they require different things. Recognition would care more about that edge thing that we mentioned. Edge detection would care more about that, but image classification would care more about feature extraction to tell which thing it is. And yes, I will share the slides. I actually have a new URL. So Isa from mlh.tech. I used my .tech domain this weekend for it. It's just a redirect right now, but it has everything that I use. It currently does not have this slide though. So let me add that really quickly. AI models versus AI tools. Excuse me. I'm going to share it to anyone with a link to view and paste it in my link tree. See, that's another example of gosh, it lagged. Another example of tool versus from scratch. I could make a website from scratch and it would definitely make me feel prouder and it would definitely be more efficient. But to get the job done of giving you the slides without making you wait for the slides, I used a tool, which is a website builder, Linktree, and it's not making me as proud because I'm not. It makes me feel like I'm not a developer because I'm using a tool, but it gets the job done. It's more efficient and yeah, it's faster and more efficient. So I might as well just like lower my pride to get the job done. And my link tree isn't running because my okay, let's do this. Link tree. Gosh. But yeah. Any other questions anyone else has? Oh, I don't think I quite answered how to select the best model. But like not counting the examples that you gave, because as I mentioned, those are more machine learning than artificial intelligence.